Now, I take slight issue with the wording of part 1. I think it could have been worded better, but it didn't stop you from solving the question. Part 1 said, show and explain why f of x has an inverse function. It kind of left off something semi-important, which is that, all functions, for instance, like y equals x squared, it has an inverse function if you restrict it, right? Namely, for positive values of x, okay? So what we mean is, what they're after is, it has an inverse function for all values of x, okay? So, how do you, actually I'll leave y equals x squared. How do you know whether something has an inverse function or not? Why is it that I have to restrict this in order to get an inverse out of it? It's a simple function. What's the problem with x squared? Why doesn't y equals x squared? Why doesn't it have an inverse function for all real values of x? Be careful. So, depending on the language that you use, right? Probably the simplest way is to think, well, okay, if I did what we talked about before, to get an inverse function, you switch variables, right? Yeah? But this is not a function. This is not a function, okay? You get this guy, which is a relation. Okay. Now what that corresponds to, the reason why you end up with a relation is because of this point here. You see why that's important? Do you remember us going over this before? What's significant about that point? It's a turning point. It's not just a stationary point, it's a turning point. Okay. So where you have something that turns around, that's what means values double up. Okay. So what I want to show is that this thing never turns around. Okay. Now that's kind of the informal language for it. Formally speaking, what you want is you want to show that it's monotonically increasing or decreasing. Okay? It's always going up or it's always going down. In other words, it never turns. Okay? It never turns. So how are you going to go about showing that? How do I show that it's never going to turn around? Well, I need the derivative, don't I? Okay? So I'm going to go to f dash. Okay? Now, probably it's a bit easier to notice that your original function is really e to the x minus e to the minus x. You can see that just by index laws. Okay, you divide through. So that's really super easy to differentiate, right? What do you get? E to the x. And the double negative cancels. Okay, there you go. Okay, so there's a couple of different things you could say at this point. Probably the easiest thing is to say, well, e to the x, right? That guy's positive. If you wanted to be technical about it, you could say for all real values of x. Okay, there's nothing you can put in there that will make that negative. Nothing real, anyway. You could say the same for e to the minus x, right? That's also positive for all real values of x. Okay, so you got two things, and they're always positive, and the sum of them will also be positive. Okay, so you can say this, and that, of course, is f dash. Okay, so what does this mean? Not only does it never turn around, it's never even stationary. It's always going to be positive. In this case, always going up. Wouldn't matter if it was always going down, but we need to have it always going somewhere. We can't let it turn around, otherwise you get into this problem. Okay, so you can say, therefore, you could either say there are no turning points, so it has an inverse function for all values, or alternatively, you could say it's monotonically increasing, therefore it has an inverse function for all real values of x. Okay, so they were looking for this. What was this worth? Was it 1 or 2? 2, right. Okay, so I would probably say your first mark is in the differentiation, okay, and then your second mark is, well, what did you do with that derivative? Like, what was significant about it that gets you to a result? So this is why it has an inverse. Okay, that was part 1. Okay, what happened in part 2? Okay, now I'll admit, this was tricky, but it was definitely not impossible. It's appropriate for a last question type question, okay? Remember I said before, there are two things you have to do to get from a function to its inverse. What were the two things?
Swap.
Number 1, you have to swap, right? And then number 2, you have to change the subject, right? There you go. Okay, so there's my function up there, okay? You really can do it either way. The maths ends up being much the same, but I'm going to do it in this order. I'm going to swap them, then change the subject. So here's what I've got. Let's just, for the sake of simplicity, rather than f's and f minuses and all that kind of thing, I'm just going to call it this. and call it y. It's just a little easier to work with the letters. Okay. Now, if that's the original, then I'll swap them to get the inverse, and then all I need to do is tidy up. Okay. So here's my swap. There you go. That's the inverse. All I need to do is rearrange this and make y the subject. Okay. Now, rightly, you look at this and you think, what do I do with this? What possible options do I have? Okay. Now, the first thing you might do is maybe try to go back to something like this. Okay. But it doesn't lead you anywhere really. Okay. What you need to do to make y the subject is think about what kind of equation is this. Okay. Now, I think probably the easiest way to see it is to multiply across, like so. Okay. And then move this guy over with all the rest of them. Actually, maybe I'll put them all on the left-hand side. This is what I've got. Okay. Now, I know that doesn't look much better than we had before, okay? But believe me, it is. You can deal with this equation. You can deal with this equation in exactly the same way that you could deal with an equation like this. Okay? Because we all know what to do with this, right? You say, what is this thing? What would be your next line after this? You would say sine x, and then you would start doing the quadratic formula, because it's not a quadratic equation in x anyway. It's a quadratic equation in sine x, okay? Now, it's a little bit hard to see because of this indice thing here, really, okay? But e to the power of 2y is really e to the power of y squared. That's just index laws, okay? Just like this is, which you're a little more used to seeing, this is a quadratic in e to the y, okay? Now, it's doubly confusing because you're like, what's that x hanging around in there for? Okay, well, exactly the same thing that this -3 is doing. He's going to be a coefficient, no problems, okay? So just like over here, my first instinct is sine x and launch into the formula. What I'm going to do here is say e to the y, and then I'm going to launch into the formula. What do I get? What's negative b in this case? It's just x. That's the coefficient I'm after, okay? Plus or minus, and then you launch into this guy. That'll be b squared minus 4ac. There you go, double negative will cancel. All over 2a, which is just 2. Okay. That's the hard step. That's the hard step. Seeing this and recognizing it's just like this, which you've done to death. Okay. This thing here, x plus or minus the square root of x plus 4, you also need to be watchful for, okay? Because have a look at this guy. I've got two solutions here. Do you expect two solutions? No, and in fact, not only do I not expect it, I don't want two solutions because I rubbed it off. Two solutions is not an inverse function, it's an inverse relation, okay? So I have to resolve this somehow. Now the question is, how? How can I get rid of one of them? Obviously one of them is bad. I have to reject one. Here are the two options. You've got this guy, and then you've got this guy. Okay, and one of them is bogus. The question is which one, okay? Think back to something we looked at in period 0 today, in the 2-unit exam, okay? We actually have some restrictions on these. At least we're supposed to. They are implied in the equations we've got here, okay? Because these are supposed to be equal to, allegedly, e to the y, right? Well, e to the y can't just be equal to anything you like. It's restricted. Where is it restricted? It's positive, isn't it? Whatever value of y you stick in here that's real, you're going to get positive numbers, okay? So therefore, I should expect these guys to be positive, right? This looks like it presents no problems. I can stick numbers in there. But this guy's an issue. Why is he an issue? Yeah, this guy here. The square root of x squared plus 4 will always be bigger than x, every time. So you're taking, it's a small number, take away a big number, this guy's negative. It's not going to work, okay? So that's why I can reject that solution. I can say, I only want this one as what it's equal to, e to the y, that has to be positive for all the values of y. Okay, so that's how I discount that solution, and that's a mark right there, really. Okay. Okay, I am almost there. What was the point? I did the first thing, which was easy, which was switch variables. The second thing I need to do is change the subject. I'm so close. I want y equals, what do I do both sides? Take logs. Okay. That is 3 marks worth of work, isn't it? Okay. If I was marking this, and I did not, but if I were, the places where I would expect to see the 3 marks are, I wonder where you would put them. I think I put my first one here. Rearranging this and seeing I can put it into the form of a quadratic in e to the y. That's hard, okay? Next step here, getting the quadratic, getting e to the y being the subject, and then my last step down here, making it log whatever, okay? This was really interesting because they said solve this, they said hence, they put it in big bold letters, and they even said don't solve it as a quadratic, which should have been that other alarm bell to say, right? It was a clue. Anyway, so the question is, well, how else do I solve it? How else do I solve this thing? Well, this guy, I recognize this guy from the earlier parts. That's f of x. Okay? So what I really want is for f of x to be equal to 3. If I get there, I'm fine. Okay? Now stop, think. It said hence. So you have to take everything you just did over the last 10 to 12 minutes and think, how does that relate to this at all? Well, the bulk of our effort in this question was spent on getting an inverse. Okay? This is actually not y. This is properly speaking because the terms they gave it to us in were f and f inverse. So we spent all this time getting an inverse. What are inverses for? Right? Inverses are for undoing the original function. That's what an inverse does, right? So if I take f inverse of the whole lot, f inverse of this, and f inverse of this, right? Well, this should collapse, right? That's what an inverse is all about, okay? It's just x. And so this is going to be 3 plus the square root of 9 plus 4 is 13. On 2.